Okay, alhamdulillah, salatu wassalamu ala rasulillahi wa ala alihi wa ashabihi ajma'in wa ba'd. Alright, that's great. Let's get started with a small topic that we are going to study in this whole session. It just requires one session and that is enough. So it's basically linear law. But before we jump into the linear law, we wanna make sure that we have the concepts for modulus cleared. So modulus basically means the absolute value, where you just remove remove any signs. You only care about magnitude, the value. So modulus of positive 3 is 3 and modulus of negative 3 is also 3. To remove modulus, we have to square both sides, and modulus sign will disappear from the entire equation. For example, modulus of 3, if you square both sides, it becomes, which is equals to 3 squared, so 9 equals 9. And squaring negative 3 modulus is equals to 3 square, which is 9 equals 9. So this is just an example. So whenever you have an equation, let's say an equation like this, and you are given to solve for x, okay, so you're given to find the values of x which satisfies this equation, which means left hand side would be equal to right hand side. 2x minus 3 modulus of this equal to 4x plus 5. So what should you do? You just square both sides, and when you do so, what happens? You expand using the a plus b or a minus b whole square formula, and then you just solve the quadratic equation. Okay, you combine like terms, bring everything to one side, and solve it using a general quadratic solution, and from here you would get two values of x. Okay, did you understand, Hamad?
Yes.
In that case, so can you please try and solve this question that you can see below? Modulus of x minus 5 equals 3 times modulus of x minus 2. Can you please tell me what is the first approach that you would take in order to solve this?
I'll square the both sides and then do the same as the previous one.
Exactly, and here you see that there is modulus on both sides. In the earlier there was modulus on both sides, one side, but that doesn't matter. When you square both sides, both of the modulus will disappear, and exactly you are on the right approach. So please let me know after you are done finding the final answer. Yeah, so the procedure is the same. Square both sides and you get a quadratic equation. So what did you should get two values of x. What are your values?
1 by 2 and 11 by 4.
Alright, in order to verify that, what you have to do is we put this entire thing in the Desmos, and you will find two values here. So one is 1 by 2 or 0.5, and something is in between, this is 2.7 and 2.8. In order to get the exact value, here we don't get the exact value when we click it. So alternatively, what we can do is we can graph these two things and find the intersection. So one value is 0.5 or half, another one is 2.75. So 2.75 means 11 by 4. So did you get these two answers? Alright, that's great then. So you now understand how to solve equality with modulus. Similarly, if you have something, a question like this: solve the equation 4 minus 2 to the power x modulus equals 10, giving your answer to correct with 3D significant figure. So in the same way, what you have to do is you square both sides and then expand the entire thing in the formula a minus b whole square. So a is 4, a minus b whole square. A is 4, so you expand 4 square minus 2 using this formula, and then you have to take a substitution. 2 to the power x, you take a substitution to any other value. I chose a. You could choose any value, y, but not the same variable. Okay, you could choose any other variable, and then solve the quadratic equation that you found for the substitution. After you are done finding the values for a, then plug back the substitution. So let's say if a equals to 3, then you would find 2 to the power x equals to 3, and then you solve for x. Hamad, can you tell me how would you find the value of x from here? What is the procedure? Yeah, you could just use any logarithms. Log base 2 works the fine, that's great. And basically any logarithms, you can use ln or log, and then after doing so, x gets here and you will be able to solve for x. That's great. So you already know how to solve these types of questions. So now let's jump into our main topic for today, which is linear law. It's very important for physics if you're doing A2-level physics as well, for P3 and P5, where it helps a lot. And obviously in maths, in the topic that we are studying, there are questions from past papers. So linear basically means a straight line, or whenever you have an equation of this format, y equals to mx plus c. Now read carefully. This y means quantity on y-axis and x means quantity on x-axis, which means the quantity could be anything. It does not necessarily have to be just y or just x. Okay, on that's why it's written capital Y. It means that whatever is on the y-axis equals m, which is the gradient or slope, times x, the quantity on x-axis, plus c, constant or y-intercept. So here is an example, as you can see on the screen, on my slide. Here we have v equals to mx squared plus c. In the y-axis we have v, so you put v here. In the x-axis we have x squared, so you put x squared here. So v equals to m, which is gradient, x squared plus c. Okay, so what you have to do is, after observing the graph, you formulate this general equation for quadratic, and then you equate like terms. I mean, to perform you compare the coefficients. So let's say if they give you the equation v equals to 5x squared minus 3, from here you can say that gradient is 5 and y-intercept is negative 3, but just by comparing the coefficients, right? Similarly, if the y-axis has ln y and on the x-axis you have x, it would be ln y equals to mx plus c. Similarly, if you compare, gradient is 2 and y-intercept is minus 3. Okay, for this graph, if you change the variables to get y and x, then you won't have the same graph. The shape will be different. So that's why if you find the gradient from 2 points of this graph and the y-intercept, you can't plug it to an equation for y. You have to plug it here on the equation, because this is for which it is defined. Like, we have ln y on the y-axis, we don't have y. Okay, so similarly, if it is 1y and x cube, again, anything in the thing present in the y-axis equals m times the thing present in the x-axis plus c. Okay, so here we can again find the gradient by comparing the coefficients. Y-intercept is 1, gradient is 9, no strings attached. So now we dive deep into the into solving questions regarding what we have learned. But before that, I would give you the floor to ask any questions or confusions if you have.
Okay, how do we compare the x cube with x?
Yeah, that's why I said that this is capital X. This means that whatever is in the x quantity. So what I'm trying to say is, we won't have a linear relationship between y and x because it's cubed. But if we graph 1 upon y on the y-axis and x cube on the x-axis, you would have a linear equation. That's why you have a straight line. So this x means whatever is on the x-axis, and this y, capital Y, means whatever is on the y, whatever is on the y-axis, and then you compare this to find the gradient and slope of the straight line.
So we are saying that y is equal to 1 by y.
No, this capital Y is this capital Y represents the quantity of y-axis. So yeah, in that sense, capital Y equals 1 upon y. But like there is no use for that. Like you can't formulate an equation and solve the unknown or something. This is just a symbolic way to represent whatever what is the thing on the y-axis. Okay. All right, that's great. So basically the question will be like this. So they will give you an equation y equals to a times e to the power x square, and they will say graph of ln y against x square is a straight line. Obviously we know that this is not a straight line. We know the graph of exponential, right? Like it's something like this. You won't get a straight line. You could get like this, you could get like this, you know. But if we plot ln y against x square, we will get a straight line. Find gradient and y-intercept of this line. So you have to find the gradient and y-intercept of this line. How would you do so? So start from the given equation. They have given the original equation to be this, right? So you convert this equation to get ln y. So introduce ln. Then perform the laws of logarithm. You have, if two things are being multiplied, we can add them. So I split the log, and then whatever is in the power gets multiplied with the, you know, x square. It becomes here, and then you just make it rearrange to, you know, comply with the y equals to mx plus c format. And after you're done with this, now you can compare the coefficient and say the gradient of this line is 1 and y-intercept is ln a. So have a look at this problem again and ponder and reflect. Let me know whether you have understood it well or not. Yeah, so linear law basically deals with straight lines, and this thing capital represents quantity on y-axis, and this thing represents quantity on x-axis. So here, if you have d plotted against t, then it becomes d equals to mt plus c. You have d plotted against t square, it becomes d equals to mt square plus c. If you have 1 upon x against x y cube, you have 1 upon x equals to m y cube plus c. If it's 1 upon y upon 1 upon it's 1 upon y against 1 upon x square, then it's 1 upon y equals m times 1 upon x square plus c. If it is ln y and x square, then again ln y equals m x square plus c. And then what you have to do is you just find the m by taking 2 points. You know how to calculate the gradient, and slope is the y-intercept. If it is visible, if you can directly find it using that. Otherwise, you know the format of y equals to mx plus c and finding the y-intercept. You know this?
Yes.
Alright, that's great. That's so if you have ln y against ln x in a similar way, that equation would be ln y equals to m ln x plus c. So if you have understood everything, can you please try and find the gradient of this line? Y equals to 5 times e to the power 3x. The graph of ln y against x is a straight line. So they have given you the hint that if you plot ln y on the y-axis and x on the x-axis, you'll have a straight line. What is the gradient of that line? Alright, so the gradient is 3. And just in case if you're interested in the y-intercept, that is ln 5. Did you get the same answer?
Yes.
Alright, that's great then. You have perfectly understood the concept, and that makes you eligible to solve actual past paper questions, and we start with this one being the first. Alright, so they have asked us to find the value. Use the diagram to estimate the values of a and n. N equals to 0.267 and a equals to 2.013. We don't have a perfect reading like this, this dot. So it is 0.4, but the middle is something here. So it's just below the 0.8, not exactly 0.8, because you only care about the middle of the cross. Okay, middle of the cross is slightly below this line. Same for this, same for this, same for this. So actually the best approach is to draw the line, a straight line, best line of best fit, and then take 2 points, good points from the line. So we have ln y and we have ln x, so ln y equals to m times ln x plus c, and then so there's that after you find the gradient, you just that becomes equal to n, so n is just your gradient, and you have to do some workings for finding a. Whatever you find the value of c, so ln a is equals to 0.7, and we know that ln has an e, so when you what should I say, yeah, the actual proper method is to introduce ln to the base e here. So you have ln a, right, equals to 0.7. You introduce ln a equals to ln e into 0.7. okay, now we know that this comes here, so ln a equals to ln e to the power 0.7, and then we cross out the ln, so a equals to e to the power 0.7. so this would be your. So in order to solve this question, the variables, okay, let's see, the variables x and y satisfy the equation x to the power n y equals c, where n and c are constants, where x equals to 1.1, y equals to 5.2, and x equals to blah blah blah. Find the values of n. Okay, so they have given us two sets of values basically. So first of all, we know that this x to the power n is not linear. We have to convert it to the format of y equals to mx plus c in order for it to compare it with the in order to make it linear, a straight line basically. So but wait, oh, it's in a second. Explain why the graph of ln x is a straight line. Okay, so in order to find n and c, first of all you plug in the values. They have given us x equals to 1.1 when y equals to 5.2, and x equals to 2.2 when y equals to, plug in, put in the values. Here we have one, here we have another one, and then we know that c equals to c, so perform c equals to c. If you do so, bring this thing here, and you can bring this thing here, and you can take n common because both of them have power n. Introduce log, and you find the value of n from here, and in order to find the value of c, you plug the value of n again here, and you find the value of c. This is how you find. So please try it again and see whether you get you are able to reach the correct answer or not. Yeah, so you have n equals to 1.498 and c equals to 5.998, and then explain why. Explain why. He said what, minus?
Yeah.
No, it's not minus. Minus gets cancel out. From here you get you just calculate this thing, divide by this thing. It should be plus, it's not minus. 1.498, 5.998. Explain why the graph of ln y against ln x is a straight line. Why?
Because it follows the equation y equals to.
Bolo.
It follows the general equation.
Because it follows the general equation of y equals to mx plus c.
Brilliant.
You actually have to perform this calculation and show that how does it follows. In the first part you did not show that. You just substituted given values and just solved simultaneously and found the values for unknowns for n and c. But in part 2 you actually have to use logarithms to convert it and show here is the proof. Capital Y equals to mx plus c. So please try and try and see whether you get the same results or not, without seeing, of course. Here you should get ln y equals to negative n ln x plus ln c, and then you have to show it that this is comparable, or what is the right term? It is similar, or it is yeah, comparable to y equals to mx plus c. So you get this equation.
Of course.
Oh, yes.
The equation is in my plot.
Alright, so here is the next question.
Cut a man and the tree.
Alright, so here is the solution. They have asked us to find the values of a and k to two significant two decimal places. So 0.42 and 2.80. If you write 2.8, you will get -1 because you didn't write 2.80. Two decimal places, not two significant figures. So, what is the procedure in solving this? First of all, the variables x and y satisfy the equation. This they've given us an equation where a and k are constants. The graph of line ln y, the graph of ln y against x y is a straight line passing through the points they've given us shown in the diagram. Find the values of a and k correctly to significant figures. First of all, they have given us 2 points, so label this x1 and x2, and this to be x2 and y2. So you find the gradient y2 minus y1. First of all, you find the gradient, and then you use y minus y1 equals to mx minus x1. You find the equation of this straight line. This is y equals to negative 0.419. This is basic coordinate geometry. Just find the straight line, but here you use capital Y, and then after you're done with this you have to you have to compare it with the thing that the equation that they have given. So here you have a straight line. Now what do you do is you use logarithms to convert this to straight line and then this capital Y gets replaced with the actual quantity of y, which is ln y, and this x gets replaced with x squared, and then you compare the coefficient. Negative k equals to 0.419, so k equals to 0.42, and ln a equals to 1 point this, and from here you get the value of a.